Hello, I'm Matthew D. Perry of Perrywise IT Consulting. Today on Getting Wise with Perrywise, we'll be covering the OSI model today on the Network++. I hope you brought nachos. You may be asking, what is the 7-layer OSI model? It is defined as the Open Systems Interconnection model. It is essentially how a network operates. We've devised it into several different layers, each handling specific tasks from hardware to software, data handshakes and whatnot, and we're going to be going into each layer individually and seeing what happens. For posterity, the 7 layers are as follows: physical, data link, network, transport, session, presentation, and application. We'll be going into those later a bit shortly, let's say about now. The application layer is closest to the end user. This one interacts with the applications that use the network. If your issue includes HTTP or HTTPS, that's a dead ringer for an application layer issue. It also interacts with other applications across the network. Next is the presentation layer. It translates application data into network data. It encrypts data as it sendings and decrypts data upon receiving. The session layer controls sessions between hosts. That means it establishes, manages, and terminates connections between applications. The transport layer is the section of the network where data is segmented, reassembled for communications between end hosts. It breaks large pieces of data into smaller segments, which are less likely to cause transmission problems. This provides end-to-end communication, aka host-to-host communications. The network layer provides connectivity between end hosts on different networks. It provides logical addressing and path selection between source and destination. Any routers on the network will operate at layer 3, so if you have an issue with your router, you know where it is. The data link layer provides node-to-node connectivity and data transfer. It defines how data is formatted for transmission over a physical medium, i.e. cabling. It detects and corrects physical layer errors. It uses layer 2 addressing, which is a separate thing from layer 3 addressing, and switches as opposed to routers operate on layer 2, so if you have an issue with the switch, you know where that is. The physical layer defines physical characteristics of the medium to transfer data between devices. This varies between voltage levels, maximum transfer distances, physical connectors, cable specifics, etc., and this is when digital bits are converted into electrical or radio signals. Finally, we have the Transport Control Protocol/Internet Protocol, or TCP. It's a conceptual model and set of communication protocols used in the Internet and other networks. There are 2 foundational protocols within the suite, hence why it's called TCP/IP. It's a similar structure to the OSI model, but it has 5 layers instead of 7. I just like to cover all 7 because there's more data that way. But a lot of modern networks prefer to use it, so I figure I'd let y'all know it exists. In today's Get Wise with Perrywise, we messed around with the OSI model, and we got wise that people don't need those stupid packets anyway, if you know what I mean. Till next time, I'm Matthew D. Perry at Perrywise IT Consulting.